Okay, so I think we should start now. So thank you so much, guys, for taking time and like joining this session. So we have some new joiners as well. Like two of them are new, and others we are like co-workers. So we have two more, like Yogesh and Majid today. So I would like to like first introduce myself so that others know us, and then we'll just uh, go to the session and stuff. So first of all, my name is Mohammad Tokir Nasir, and I'm basically from Pakistan. And I'm now currently working in TradeLink.com as a senior full stack engineer. So today we're going to like have this session where we'll discuss about a tool that we are working on. So I'll just now ask Mink, can you please introduce yourself so that the two new joiners know that what do you do and your name, etc.
Yeah, hi everyone. My name is Ming. I'm working now as a full stack developer with Tokyo at TradeLink.com. Um, I started working full time around 2 years ago, so I have 2 years experience. Right now, I'm learning React and TypeScript, and I've learned a lot from everyone in my company. And it's my pleasure to meet every one of you. Hope we can work together on this project.
Yeah. Okay, Akshat.
Hello everyone, my name is Akshat. I'm a senior developer advocate at TradeLink. I hope most of you know me. So I do a lot of tech evangelism and I make sure that engineers succeed in what they want to do. And apart from this, I contribute in the open source in multiple way by speaking and by writing code as well. So looking forward to contribute with you all. Thank you so much.
Pranjal.
Hello everyone. I am also working at TradeLink, and I mean,
What a
so I
coincidence.
Yeah.
joined two months ago, and it's been really nice. My growth curve has really been like very like the growth curve is like exponential, and I'm really enjoying what I'm doing these days, and I'm really learning a lot from my coworkers as well, and I really hope to contribute to TSSSG. Yesterday also I was like going through the code, and I found something like which I can contribute to really well, and it can improve the parsing performance of the reducer. I
Nice.
mean,
And that's what we need, man. That's why you are here.
so yeah, happy to contribute and learn from you guys as well.
Abdullah.
Yes, hello everyone. My name is Abdallah. I'm also a coworker with them, TradeLink.com. Yeah, I'm working in TradeLink as a front-end engineer. Yes, that's it.
Cool. Yogesh.
Yeah, hi all. My name is Yogesh Kathad. Basically, I'm from India and currently I'm working as a full stack developer here in Dubai, in a IT company. And yeah, I'm looking forward to contribute with you guys.
Nice. Majid.
Hi guys, this is me Abdul Majid. I'm from Pakistan. I have been working as a React.js front-end developer for past 1 year. I'm looking forward to work with you guys.
Thank you. Okay, so one more thing. Majid has been like my ex-colleague in Pakistan, and he's the one that I trained myself. Like he's he's like very extraordinary guy. Like and I really love like he's here today because I insisted him to like be a part of this so that he could learn something new. So I think we should start now. So I'll share my screen. Okay. So I hope everyone knows that why we are here. We are here because of this TSSG, which is the Swagger schema generator that we are working on. So at very first, like I would like to have like this demo here. Let me clear this out. We have this basic editor, which this is a POC, simple POC, which allows you to like write the TSSG syntax and then pass it to the Swagger schema specification. But this POC only allows you to transform the object schemas. It doesn't allow you to like work with all like fully qualified uh, open API spec, but we are working on the new syntax, so that's why we are here today. So we'll discuss the syntax, and we'll like have some discussion for how we can improve the overall uh, like developer experience and the syntax, and or maybe it's called the grammar. So this is the basic structure where like this is the basic like proposal where we write the object if we want to like have an object in a request body response, because we are going to have objects in many uh, ways, like in paths, in request bodies, in responses, and so many places. So this is the most important part in this whole TSSG. And this is like how we currently write a simple like object which transforms to the OpenAPI spec like this. So I hope you have already tried this. So today, the purpose is to go beyond the limits of this POC, because we want to like have a way where we could write a fully qualified TSSG so that we could get the fully qualified OpenAPI spec. So I was like working on some things like how like a proposal draft so that we could like have a way to introduce the schemas, the request bodies, responses, and paths into the TSCC syntax. So this is what I was like playing with a few hours ago. Like we can have a way like we do in TypeScript. So this is a bit stolen from the TypeScript and GraphQL, and I just merged them into like one so that we could like have a way to express our schemas and paths in an easier way so that it is easier to understand, easier to extend, easier to write, and then we can like have a fully qualified transformation into the OpenAPI spec. So this is what I was like considering, that we can have a schema block. Okay, schemas block will contain all the schemas. Okay, then we'll have a request bodies block which will have the overall all the request bodies the same way we have in the OpenAPI spec JSON. So similarly we'll have our responses, and similarly we'll have the paths like this. Okay, so the main thing which is interesting is like we can have this kind of syntax. Like this is again going to be a block but of schema expression. Okay, so this user expression, like it's a schema expression, is going to be like named as a user, and it will have these two properties which is called name and age. And then let's say we have one other, we can add like this, and then we can have something other that extends this user. So this is how like I'm proposing this syntax, like we could extend the existing uh, schemas so that we don't need to repeat ourselves. So there are two kind of variations where we need to extend in different like situations. So one is sometimes we want to use the existing schema, but we want to namespace them into some other properties like I have done here. So this is like simple referencing, like info is a key, and then the value is going to be a reference to this user. Okay, and then similarly we have this kind of syntax where, and look, this is going to result into this like info and then this thing. And on the other way, this extend means it is going to like if you like I know that you guys are familiar with the object oriented programming, so we like have like a way to extend one kind of class, and like from class like we have a class A and then B, then if we extend the A into the base, so it will have all the properties from the like superclass in, and the its own the child properties that the child class has. So this is similar structure. So in a similar way, we'll have a request body block where we'll have this kind of like again structure, but they're going to be like specific, because there are so many things that are only in schemas but not in the request bodies, or maybe sometimes in the paths. So I was like working with these paths, and I feel it a bit more complex than all other things, because responses, request bodies, and schemas are going to be almost the normal objects, but the paths is more complex because it is going to have some additional properties like description and some meta data about it, and then it will have a request body and responses and stuff like that. So this request body, either we can just write it into it like the way we could write the object and define all the things, or we could like reference it like this, like request bodies dot get user, so it will automatically get this one, like it will just give the reference. And similarly we can have this kind of responses as well. Like in responses we can have multiple type of responses, like it's a 200, 400, 500, maybe something else. So we can have a way to like mention like this, or maybe if we want we can like do simply, if it's a 200, then if we have all like some global errors or something like I don't know, but I was just experimenting some of the syntaxes, and we can have like error stored, which is going to be a simple basic error. Like if it's sorry, it's not there, it should be inside this. Yeah, my bad. Errors.404, or maybe some basic 404, so that it is easier for us to like mention and just reuse the code as much as we can. And then there is one more challenge, like this is going to be a one whole single file, but we want it to be like a way so that we could split it into multiple modules or multiple files. So the basic the structure is going to be the similar like this. So what we'll do is that what I was thinking, we can write the mergers for it so that we could like traverse the whole project tree, and then let's get all the TSSG or maybe SSG files, and then combine all the schemas into one place, request bodies into one place, and then similarly the paths, so that it is for easier for us to like traverse and build the ASD for this. And one thing that is interesting about the stages is like this. We'll have two stages for the whole transformation from SSG to OpenAPI spec. Is in the stage one, we will have the parser, which will build the ASD, which is called the abstract syntax tree. And then on the second stage, we will get that ASD and we'll write a transformer. At that transformer, what it will do, it will traverse the ASD tree and then generate the OpenAPI spec. Okay, so the benefit of writing parser and transformer separately is huge. I'll explain why. Just look at this. I was playing around with some syntax here, so let me just.
So just to pause you here in between, sorry,
No.
just a quick question. So right now what's happening is we are just using the current input and just parsing it, passing it via AST and transforming it to the OSAP, right?
Yeah.
The open source. And so you're suggesting to split it into two parts right now.
Problem is before this, I was using the ES Prima, and I was using the ASD of a JavaScript object. Okay.
Well, limits you to the syntax of JavaScript.
Exactly. The problem is this works well with simple like JavaScript object notation. But the problem is if we want to extend this kind of syntax, we cannot do that because we will not have that kind of ASD, because ES Prima is only valid for JavaScript syntaxes. But this kind of syntax is not a valid syntax in JavaScript. So we cannot have a complete ASD for this kind of stuff. So we'll need to work on our own parser so that it builds the ASD for this kind of syntax, like that's very specific for TSSG. Okay. So this was a limitation, but this worked well for the POC. Like the current working POC is built on this ES Prima ASD parser. And I just wrote a middle like transformer, which transforms from ASD to the OpenAPI spec. But now as we are like working on to improve this overall syntax, and we have a lot new things that JavaScript doesn't support. So we'll need to figure out how we're gonna like do this. So that's why we're gonna build our own parser, which is I'm already working on. And so look at just this. This is the same structure schema, which is going to have a user and then employee and then a v2 employee. So I have already done this kind of syntax parsing, and it is giving me this kind of AST parser. So which is like returning me, look at this. What I call it, it's a schema block. Okay, so just look at this. I've got in the first place is schemas block expression. Okay, so as we know that inside the schemas block expression, we can only have schema expressions. Okay, so this is a single schema expression, which is named as user, and then we'll have some object and properties. So inside that, look at this, the properties, like this body has an array of different object schema expressions. Okay, so this schema expression was named as user. So look at this, the name of the schema is user. So we have a meaningful data. And similarly, the body is, because this is the body of this, and this body is an object expression. So it will have a simple basic object. And then the properties of this object are going to be an array of these two. So similarly, we have a key, which is of type identifier expression, because this is an identifier, not a literal. Otherwise, it will like this. Okay. So then similarly, we have this name, which likes the string, which is a value. So value is also of type identifier. So that's why we have identifier expression, which is 7. So the main thing is we have name as name, and then value dot name as string. So we have got these two in place. And similarly, we have this age and number, which is age and this number. Similarly, we have another schema expression, which is this named as employee, which is again going to be a simple object expression, and then it will have its own info and salary as properties. And this is the interesting part, where it is extending the user. So similarly, we'll have a very simple way, like schema expression, extend, like it extended this, I think I have a typo here, I'll fix that. So user, because this v2 employee is extending this user. And similarly, the body is going to be of type object expression, and it is key value pair of the salary and the number. Now, there, while experimenting an hour ago, what I was first doing, I was evaluating the user schema at the parser's build time, like when the parser builds the AST. And it, like I was facing like a very interesting challenge, that if for some reason the syntax, like we put the definition of user below this, it was like erroring out. So it was not allowing me to like build the AST, because it was not able to find the user. But on the other hand, the way I did is, I'm just now only keeping the reference to the user, and then I'm caching all the schemas into a program node. So program node will have all the schemas named as user, employee, and v2 employee. So what it will help us, it will help us to figure out all the things in the transformation time. So we'll have, if like, let's say we have multiple files in a project, and we do not really know the sequence, like if the user comes first or the employee comes first. But if we use this kind of structure to write the transformer and then evaluate at the transformation time, we'll have a way to like complete the parser and build the AST. So once we'll have that, we can simply get the user properties and then the employee properties. And if they want it to be a static, they can be merged. If they want it to be dynamically like referenced, we can just simply put the references. So it will be a lot easier for us to like build the actual transformer which works with all the things that we want, because we will have a way to define a TSSG RC file. So RC file will have some kind of configurations where they will be able to like put some options so that it works the way they want it to work. So let's say, let me open the other like old project. Oh man.
How about we use Babel for custom syntax rather than rewriting the whole parser?
Babel is specifically for JavaScript.
Yeah,
Okay,
but you can
so
use your custom syntax.
yeah, but it will be a lot like a very difficult task for us to like do if like it's very easier for us to maintain if we do it from scratch, and we do not need to learn so many things that JavaScript ecosystem like adheres with, because we don't want to like go into the details of JavaScript. We are going to work on our own kind of syntax so that it is easier for us to work on other things and extend the syntax later on. So this, yeah, test TSSG. So look at this. A simple, I just implemented a simple TSSG compiler to a test project where we have this kind of like structure. We'll have RC file, we'll have a Swagger directory. So where it is going to like search or put the output. So it is going to be a directory for that. And what is going to the name of the file is going to be main.json. And there are some path configurations like in our office, what we do is our actions are named as prefix, either it's a version 1 or version 2. Then we have get user, some like the name of the action, and then we have the postfix as action. So like look, this is not the case for all, like for everybody. Like somebody use the method keyword at the like as a suffix. So what we can do is we can like pass such kind of syntax like here. If we want to have action, we can pass it here. If we want to like have a default versioning, so we can have a prefix for the v1 as it is, or maybe we can just leave it out and it will not insert it. So this was a simple I think it's on TSSG. So this was the basic CLI version, so which allows you to like uh, create the schemas from within the editor or maybe the CLI. So it has the path. It asked me for the path name. So I say like I want it to be v1 get user data, maybe some name, and then it will ask you what kind of method you want to like use. I would say it's a post method, and then it will ask me for the separated tags. So global tags, so I will say it's a user tag, and then I'll just write the summary, get user by ID, for example, and don't need to, yes, I would like to go with, and then it will ask me for the response types. Like if you want to like have 200, 400, so you can just choose one of them, maybe return user data, and then it will open the editor for me, the built-in CLI editor for me. So I'll just enter my name. It will just return me the name and then age, and I can just simply quit it and it will receive the input. And then I'll go, and if I want to add more responses, I can just write the like go back, and maybe if I want to like add 404 or 500 as well, so I can just do that. I will skip it. And then you can also add the response body, sorry, request bodies. So this request body, like for us, simply I'm going to add like for the ID, which is required string. So I'll put the exclamation mark in front of the string. So it will make it required, and that's it. So when I'll go back, I need to format that. So look at this, v1 get user data. It was created for me, and look at the operation ID v1, and look at this as action. So it has like postfix, like inserted the postfix from which was taken from here postfix. Okay, so then it has a proper summary, and then description and responses of type 200, and then this all data and this schema, which is of like name of type string and age of type number. Then it has a request body, which is again, look at this required ID. I didn't have to write anything like explicitly like I want to have this required. I just put the flag in front of a type and it will automatically mark that as a string. So this is the benefit of like writing less and getting more out of it. So this was a basic introduction. Do you have any kind of question so far? Anybody?
I have questions, but
Yeah,
it
ask.
will take long time
No,
to.
no, it's okay. Ask.
So my first question: what is the vision for TSSG? Like, where do you want to take this project? And like, so suppose we did the parser thing and we created like the two-stage process, but where do you want to take this? I mean, what's the vision? What after that?
Okay.
What's
So
the
my main like aim, target, or vision, you name it, is I want to improve the developer experience for myself and for others as well, because I know that you feel like playing with JSON file is really very cumbersome and it's a very tedious task. So I'll just show you a quick demo, a little from our work maybe. Hell. So you will get the idea. So I'll just close all the files. I'll open only the Swagger file. Oh, it's a web. My bad. I need to go to the again. So this is the Swagger file, and this Swagger file, which has some of the like codes folded. So it is 4,000 lines, 5,000 lines, but this is a total of 10,000 lines. I have counted that, like I've seen previously. So editing and updating this kind of file and writing all the things explicitly is like really very tidy task. And I know that you guys feel that even if you ask Ming or Pranchal or someone else who works on like Swagger and they edit it manually, they will feel that it's a very cumbersome task to do that. And one more thing that like is it has too much of repetition. Like you need to like insert all the time the object notation and then write the type and then string, and like you need to be more explicit about this. But this is what I want to like reduce. Like just have a look at this. My computer is slow today. So just have a look. If you want to have a nested address city of type string, and then okay, and then we can have like a country required string. So look, you only wrote 2 lines and you already got like around 10 to 12 lines. Okay, so what if you have more like data which is kind of like nested something again? So you will have to like write all the things again and again, and it will like be very like difficult for you to like understand. So try to understand this code and then try to understand this structure. What do you feel is better for you to understand at first glimpse? So I bet that you will say that the left one is easier to understand and easier to write. And then this structure, which is, I know that it is a specification, but what we are doing, we are building on top of this specification so that it is easier for us to like write less code and get all the fully qualified structure here. So maybe if we are able to like take it to the next level, it maybe the Swagger will adopt this, and maybe it will be the next official Swagger tool as well. So this is why I'm just trying to like put so much work into it, and I'm just spending a lot of time working with the low level parsers and stuff so that it is easier for us to maintain, so that we could like get the feedback from the community and we could build something that really matters and that really helps people to save time, because time is money, or you can say time is everything. If you can save like 10 minutes writing the schema, and then you can just spend those 10 minutes on something very useful. And one more thing, that is will not only stop at the transformer for the open API spec. I'll go beyond this. Like what we will do is we will be using this as like a a basic structure for all the other things. Let's say if you have this structure, like it's a schema v1 user or something else, and you want this similar schema as Mongoose model as well. So what would you do? Would you like to like write all the things on your own, or would you like just to run a command so that it takes this you structure and converts it to a valid Mongoose model schema? So it will be a lot easier for us to like do such kind of stuff from this kind of syntax, so that we could produce some other structures like Open API spec, Mongoose model, or maybe ODM and ORM. So we can let's go with anything we want. So it will like help us to install the tooling. So this is what is a simple high level vision. Like we'll have an online editor, we'll have a CLI tool, and then we'll have the project editor. So the project editor is going to be similar like this, but it is going to be a fully blown editor, which will allow you to edit your project in real time. So let's say if you add a file, and this file will be displayed to you in your editor, and then it will automatically save to your project as well. So if you it's similar that you use the GraphQL playground. So it is going to be the TSSG playground, which will allow you to like work with uh, SSG syntax, and then it will transform all the Swagger schemas for you. And you don't need to like worry, you just need to install it once and set up it once, and it will work automatically for you. So it will generate all the things like typings, it will generate the models for you, it will generate the Open API specs for you. So it will be a lot easier for you to like work with. And then we'll have a support for YAML syntax as well. So I'm just working on that as well, so it will be available soon. But as we now started working on the next version, so I'm focusing on the version for now, because this next version is going to be amazing, because it will allow you to use fully qualified syntax, and you could write all the things inside the editor like here, and it will like give you all the schema at once. So it will be a lot easier for you to like work with. So this is what I showed you earlier. I have like this working ASP parser for this structure. Okay, so I just need to like repeat some of the things so that it works for the request bodies and other things. And the main part that is left is paths. So once I'm done with the paths, I think we'll be able to like work on the transformer and write the transformer. So I'm just trying to keep it as simple as possible and as similar to as the ASP parser for the JavaScript, so that it is easier for us to reuse the code that we have written already. So that we do not need to write each and everything again and again. So I'm just trying to like keep all this kind of syntax as easy as possible, and it is very like self-explanatory. So you can just have a look at it, and you will be able to like guess how you are going to reduce this to a syntax like OpenAPI spec. But I really need help with the proposal, because this proposal is kind of like very like we'll have this kind of files, like we'll have a name, and then we'll have a schemas.assg. So it will like tell us that it's a schemas. So similarly, we'll have this paths.ssg, so which will have all the paths. Let's say we have different modules. We have modules for the user, for employees, for categories, or something like that. So what we'll do is we can like write all the schemas for those inside their own respective folders. So it will be a lot easier to like just go and edit those. If you're working on the module of user, you will only have to go and look for the user folder and just find the schemas file and then edit something. You don't need to like go to a Swagger main JSON file and then searching for it and then just editing all the things manually. So this is how I'm just planning it to like integrate. So this is how I was planning it to be look like if it's going to be a path. So path is going to have a post or a get methods, and then inside these we could have like this kind of stuff like request body that I showed you earlier. So I really need help with this syntax now, because I'm not able to think of a very good syntax which is like very easier for us to understand, and it makes sense to others as well, because there are so many people who may be not familiar with TypeScript or stuff like that, or maybe not familiar with GraphQL. So I just want it to be as simple as possible, so that the learning curve for this syntax is only like a few hours or maybe one day, if at most. So that's the only like this is the reason we are here today, so that we could like discuss on this kind of
मम्मी
and
मुझे ग्रीन टी दे देना
so
ग्रीन टी दे देना रोटी खाने को
this will be
मेरी
like
कॉल चल रही है
you can put your like microphone on mute, man. Okay, so this is how I was thinking, as like we'll have a main file where we can like explain like how what kind of open
sorry guys
it's okay, no problem, man.
Can we have two?
OpenAPI 3.0, like we can mention the version, we can add the information, we can add the servers, we can add the global tags. So this main file will automatically merge to the other like main Swagger schema, so without like us doing that stuff. So this is the current project, like the TSSG parser that I'm working on, and I just set up the very basic structure and files. So it has only two parts. What is the initializer? One is the merger, and yeah, third is this core peg dot. Yeah. Okay. So one thing is I'm using peg, which is parsing expression grammar. So I'm using the peg.js, which is a JavaScript version of the peg. So it will be like a lot easier for us to like work with peg.js, because we already know JavaScript. We do not need to learn about it. Otherwise, if we use some kind of like C++ or Python or something else, we will have to learn all the things again. So it will just waste our time, and we don't want to do that. So that's why I played with Canopy, I played with OHM, I played with so many other, but this Peg.js like seems very good to me, and it is very easier to understand. And if you want to learn more about like CFGs and pegs, we can have a separate session for this, and I'll be able to like explain how this all the structure, like this syntax, this is just the grammar rule for the whole syntax that is parsing this structure. Okay, so this is like whole you can say the defined rules, so which like allows you to uh, what you can say is combine them in a way so that it is like more meaningful to the SSG grammar. So very like easy. It is the BNF. If you have like studied in your universities, the Backus-Naur form. So it is a simple Backus-Naur form, but the only thing is it is like more JavaScript way. It's not in a like pseudo BNF form, which has like a syntax where the equal sign is like a colon and then equal and stuff like that. So in other parsers, you will see this a lot, like in that we have it in Golang. So there are so many like things that are like easier for this kind of hack, because CFGs are they they are not predictable. They can have more than one path nodes for one kind of syntax. But on the other hand, this peg is very like it's better than LL and LR parsers, and but it is very like predictable. So it takes the first matched result and thus returns that. So it is very easier for us to like remove the ambiguity from the syntaxes as well, because it will throw error otherwise. So I'll surely have a session about this, and I'll teach you how we write this from a ground up, so that you start from a dot and then build a whole structure. There are two actually ways. One is top down and one is bottom up. So you can just go with anyone, so like from bigger syntax to smaller syntax, or from smaller to bigger syntax. So both are easy, but the thing is, if you want to try that, you can just go at packs.org, and it has an online version here. And in online version, they have a simple example of the arithmetic expression, where like if in universities you may have studied in a compiler construction, and you may have built something like this, where the simple parser is returning the response like it's 14. So like it's 7 and then it multiplies 2 and it's 14. So it's a correct like parser which is parsing this arithmetic expression. But what we'll do is we'll build something bigger than this. Okay, so we'll work on this inshallah on upcoming weekend. So I'll teach you how this works. But if you are like interested in learning on your own, there is a documentation as well, so that you could like go and read the documentation, and maybe if you play around, you will get to know how this thing works. So it's way easier than you think, because it's a parser builder. It's not something that we are going to like build the parser from very scratch, because we don't want to waste time on like doing the stuff that has already been done by the community. So this is like a very awesome way to like go with and write a parser, and we'll use this. So make sure if you want to contribute to the core parser, you learn this first. If you want to only contribute to the parts like the transformer, you can just simply wait for the AST parser, and once it's ready, you can start working on that if you're willing to. And there is this part, if you are good at front end and stuff like this, you can contribute to the uh, editor area. If you are good in making the CLI editors or CLI stuff, you can work into that. And if you are like familiar with mirror code mirror, and if you want to like learn how the editors work and how you build fully blown editors, so you can just search for the code mirror, and you can read about it, so that you can learn how we write the syntax parsers. Sorry, not the syntax. It's syntax highlighters and code formaters, because we're going to like need that in our project, because sometimes we'll have like people with they will like write some structure, so we'll need to like format that structure, so that it is easier for them to like read and understand. So we will do that. And I was working on the syntax highlighter, but I was kind of busy with other stuff, so I left it. But this is a basics like syntax highlighter, but I was using from the JavaScript for now. But I worked on a very CSS SSD specific syntax highlighter as well, and it's working like uh, it's a bit better now. But I'll show that you in a few days once I'm done with that as well. So it will be a lot easier for people to like understand, oh, this is the key, this is the value, this is the schema. So it will highlight the things that they need to like uh, look at and just guess what it is. Because most of the time, this syntax highlighting helps you like understand the code better. And so I'll share some files with you, like the draft with you, the one I have.
I think you can create a Slack
I've
workspace
already
for us.
created a Slack space here.
You can invite
So
us. Yes.
look at if you are into the Go community, I added some of the guys. So like there are 9 people I've invited. So Abdullah, you are one of them, and others are as well. So if you can join, I'll share all the things here, so that everyone is on the same page. And uh, I would like to like get a feedback on the syntax first, because if you are willing to like use this SSG in your projects or maybe in the future, so I just want you to like tell me, how do you want the syntax to be? How do you want it to be like as easy as possible, so that it is way easier for you to like write this syntax instead of the JSON. Okay, so
Yes.
if you have any questions, just let me know. I'll answer. If any doubts.
So before we begin working on anything, we decide on the syntax, right?
That's the only thing, man, which is like, this is a basic building block for the SSD. If we don't have a good syntax, there is no purpose to like build a parser for it.
Mm-hmm. So maybe we decide a time where everyone can provide inputs and a time where we can discuss,
Yeah,
and
that's
then we can
that's what I said.
finalize
We'll
it.
have a
So
next session in which we'll discuss a bit of this, like your feedbacks on this syntax. Maybe if you could come with your own version of syntax, like a completely different than this, and it will be like we'll entertain that. Well, like we'll discuss and we'll brainstorm on that, because we just want something like that's very easy for us to like understand and write. And as far as I worked on it, I was like able to come up with this kind of structure, and that's what I got so far. But I still think that there are some things that we need to improve. Like one thing that some like the Meebut, our CTO didn't like was this exclamation mark. So he pointed out like I like everything, but I don't like this exclamation mark in front of this. So other way is we can have a syntax like where we have the
So
TypeScript like to mark that as optional or
yeah,
not. But the problem is
I
this
think we can take a lot of TypeScript power to create
yes
some schemes like intersections
okay,
and
I'll show
unions.
you
And
a bit of mine old work here where I was I don't know if I have that now, but no, I think I've lost. Yeah, this is one thing that I wanted to show you as well. So this is the overall structure for the ASD, which is like going to be a bit messy for now, but it is very easier to understand once you are familiar with the things like how ASDs look like and how they work. So this is like gonna be a simple general nodes, a group of nodes, which are going to be a general nodes for all the things that we are going to have into our syntax. And then there will be some specific operations like schemas, paths, and parameters. So these are going to be very specific to this SSG. So in the general, we have a program node, which is going to be a root node. So this is where your ASD starts. And then one node is going to be of type literal expression. Literal is kind of like it can be a simple number, or it can be a string, or it can be a Boolean, stuff like that. And then this is identifier expression, which is going to be exactly a similar identifier that we have in JavaScript and other languages, like that starts with either a letter and an underscore, and that's it. Or maybe the what you call it, the dollar sign. So similarly, we'll have an object expression, and object expression will contain the member expression. And look at this kind of syntax. This is the regular expression, which tells that it is going to be 0 or more. Okay, so it will have a left and a right side, and left is going to be the again identified, because left is going to be the key and right is going to be the value. So these can be either the identifier expressions or the literal expressions, because we can have like two kind of keys, like either it's going to be the identifier like without the quotes, and one with the literal, which is going to be the quotes, like the string literal. And similarly, on the right side, we can have many expressions, like the value can be identifier expression, or value can be a literal string, or a value can be object, or maybe it can be an array as well. Yeah, I missed that. And it can be an array expression node as well. And similarly, the call expressions. So what is call expression? It is simple function call. So where you call a function, so you write the function name and put the parentheses and pass the arguments. So this is similarly like that. We have that already. So let's say if we have something, and we can have like one of string or number. So look at this. It gives me this something one of type string or type number. So it means that something is going to be of type either string or number. Similarly, we have all of as well, which is going to be similar, but it will be used by the OpenAPI, like this Swagger, differently. So similarly, we have enum of as well, and here we can pass some values. So this is something similar. I think I have some error in the editor. Yeah, I'll figure it out. But we have this kind of like working enum of function call as well. So this is what it calls the call expression. Okay, so this is the call expression. Like this is the name, and then this is the call, and this is the arguments list that is being passed into it. So similarly, we'll have the array expression node. So array expression node will contain other stuff, which is going to be either identifier expression, literal expression, or an other object, or maybe a call. So like it can be an array of string. It can be like, let me show you. It can be an array of string. Okay, so look at this. It is type array. Items is going to be of type string. So it is an array of string. How easy it is to express like this instead of writing this whole thing you on your own. So similarly, we can mark this as required as like this. So it will mark this as required. Look, something is now required. Okay, so you don't need to like go and write the required and then open the brackets and write the something again. You are just repeating yourself, and if there is a typo, you will not figure out like what is happening there, because if you miss an I here and you put an extra I there, or maybe if you miss here and you put it here, it will not work. Like if you generate the typings out of this, the typings will not be correct. So this is how it like saves you. Like it doesn't allow you to like it don't allow you to like repeat yourself once again, like writing this something again. So it is one thing that's like very good. One thing is we can have array of objects. So similarly we can have array of objects. Okay, so array of object name like string. So look how easy it is to write the array of objects instead of like if you want to write something on your own. So being explicit is time consuming, and this kind of syntax can save you time. So this is the main purpose of this syntax, to allow you to like write as less as you can and get as much as you can out of it. Okay, so similarly we have this unary expression. So the name like explains itself that unary expression is something like if you have an operator which accepts the only one argument. Like you have seen in the JavaScript, we have unary expressions like plus plus, minus minus. So these are unary expressions, or the exclamation mark itself is a unary expression in JavaScript. So when you mark something as this is a whole unary expression, and this unary expression is of type exclamation mark, and then it has this as argument, and this argument can be a statement like an expression, and it can be anything, any valid expression. So valid expressions can be a simple object, a simple array, a simple member expression. So it can be anything. So you can put almost anything here in the argument place, so it will work out of the box. So similarly, we have this block expression. So the simple block expression is something that starts with a block. The similar way we have schemas block. So those schema block is going to have some expressions into it. And those expressions can be 0 or 1. Like it can be empty or it can have other expressions. So we'll define what expressions they will have. So whatever this expression holds, it will going to be allowed inside this expression block. And this is what that is very specific of like to what we have. This is schemas block expression, and this schemas block expression is going to only have the schema nodes. It will not allow any other node into it. Similarly, the schema node itself is the schema name followed by the object expression. So it is going to be like something that has a name, and then in front of it, it is going to have an object expression. So we are reusing the basic one, like this one, because we don't want to repeat ourselves. So this is how easy it is to like reuse this kind of rules into this kind of PNFs. And yeah.
Sorry. So among these nodes, what is already available in the existing JS AST?
JS AST only has the object expression for us, like the object AST for us. We cannot like
How do we do the block detection and other things in
yeah,
AST?
that's what I'm going to explain in the next session. Don't worry, I'll cover all the things. I will explain how I built the schema and the blocks parser so that it verifies that I have correct schemas, and then only the valid schema bodies, like the schema nodes. So I'll explain everything, don't worry. So similarly, we'll have request bodies block expression. Like we have a separate request bodies, and then it will only have the request body expressions into it, so that it is easier for us to like put some additional information into the AST, because we want to like learn more about, because some like the way schemas can extend, maybe there is no way to extend the request bodies in the Swagger, or maybe if it's not there, maybe we can write something that statically like extends it. so that if something is changes, we could like put all the things statically into it instead of referencing that. So it will be a lot easier for us to reuse the again request bodies. Similarly, we have this, or maybe one more thing that came into my mind is what we can have is we can have a way where could we have a flag where it could have like we could write the ref or maybe the static one. So which will like tell us that user want it to be present statically. So like it will be only be used once. So once it's done, it will like put all the values without like referencing the old one. So we'll figure out how we can like make it better. And similarly, the paths block expression and then paths expression. So I was try to like build this tree, pseudo tree, so that it is easier for you guys to understand how things are working and what contains what. Otherwise, it is very ambiguous and very difficult for like some newcomers who are new into compiler construction and parsers, like understand how things are like building upon one and each other. So it is going to like help you understand some basic uh, like things about like how you start from a program node, which is a very basic node, and then you extend it so that it accepts like almost any kind of expression or syntax that you want it to. So this is pretty much it. And I think I'm done with the discussion. And if you have any kind of like suggestion now, so that you could like give
Okay.
us some inputs,
You
it will be very
suggest,
good.
do you have like something like a Trello board or something to manage? Like
No,
we can go there and see what is missing, what we
yeah,
can contribute in that.
me and Akshan first decided to go with shallow, but then we then again decided to go with the roadmap of GitHub. So we have, uh, let me go,
Okay.
TSSG-editor. So we have, I think in the TS, it's not here, it's in the TSSG. Let me go there. Yeah, it's TSSG.
Yeah. So
So
GitHub roadmap is pretty cool.
yeah, it's pretty cool.
So
We have this
it's
roadmap where
easy,
we
and
have
then we don't
things
need to
like
move
what
to
we're gonna
another
have
system.
and what things are going to be done into it. So
Yeah, it's the same. It's
so
nice.
it's same like shallow, but it's not
Just
shallow. So
yeah.
the good thing
Just
is,
something to go
yeah,
into it.
the good thing is it allows you to like add or like show like you can like
Yeah.
what you can do is you can go to code and you can have a PR and then you can go to this PR and PR can be like automatically be assigned to that project roadmap. So it is very easy for us to like go with such kind of things. So
This
we
nice.
already like the way we are like uh, creating PR is very like it's very good way to like to like we're explaining each and everything in the PR so that it is very easier for us to like go and write the document for it. So what I will like have to do is only copy and paste this into the documentation so that we do not need to repeat ourselves again and again just to improve the documentation. So this is how when I worked on the one of support for the TSSG, I created this kind of like PR where I explained it to myself because I was working alone that time. So but two of them were here, like the Akshat and Ming were here. Thanks to them, they helped me a lot. So this is how like I explain each and everything so that it is very easy for us to like put it into the documentation. And then we also had some future plans for this so that it is like clear to us that we are going to like open this kind this PR or maybe this part of the code so that we could like build something and improve it on for, like further. So this is how we like have a simple checklist where we like check that it's building and its prettier has been run on it so that it works pretty well. And thanks to Ming, she also worked on some tests for me. So we have some basic tests here. So it's kind of amazing that we have all the working tests. So whenever we change something, we just run test and we figure out if it's breaking something else or not. So this is something that we have in our project and it's very good. Thank you, Ming, if you are listening.
You're welcome.
And we also try to like have some other examples so that it is easier for a person like people who are visiting this editor so that they could understand how the they can write different kind of structures into the SSG. We also try to add the documentation within this editor so that it is easier for you to like go and check if you forget something and you do not know how to use that, so you can just go over and use that. But we really need to like improve the syntax, because this is the only the bread and butter of the SSG. And once we are done with the syntax, I'll just roll out the ASP parser as soon as possible, because I know that it's half of the SSG parser, the new parser, has been done. Okay, I'm just improving the underlying structures and the infrastructure so that it is easier for us to maintain it. Because the way I'm doing is I have this merger, a simple file merger, which merges my two of the files, which is the init and core pack.js. Because you can also write the JavaScript here, the initialize, where you can initialize things that you need to like you can have a cache, or you can have parser nodes, or maybe the node builders or something else, or utility functions here. But the problem is it doesn't highlight and gives you hints like we get into the JS. So what I did is I separated this two things into this. So now we have this kind of where we'll have the proper syntax highlighting for JS, because it is a JS file. So it just takes this and just pastes it to this auto-generated, and it is something that we are not going to like update. And this is also ignored by the Git, because we don't need to have it to run the compiler. And then I have a very basic structure where I have like this build script, this merge script, and dev script. All you need to is run the dev script, and it will automatically watch for the changes to those two files. And then once you are done, it will automatically merge that and build that. And once you build that, you can just use that into any project, or maybe if we have this like personal like folder examples where I test my things. So let's say if I change something in the parser, and if my dev is running, yes, my dev is running. So look at this. Whenever I change something into it, it just runs and builds something for me, like the parser for me. And this parser is available inside this. So I'm just requiring that parser. I'm just using this example string and then parsing my this string using this parser.parse, and this returns me an object. And this object, I'm just stringifying that, and it's just outputting the structure for me. So this is how easy it is to like work with such kind of like environment where you can choose like separate things, and you can like just watch for the changes and build something that you need. And it will be easy for us to like separate the like what you can say is the separations of concerns. So it's kind of like good now. And there are so many things that like I need to improve into, like most of them is the data structures for the ASD, because this is the important part. Because if in future we need to add something else, and if it has some break changes, so we'll just completely like break so many things in the parser, maybe in the transformer. And if we like, I don't want to like keep rewriting the transformer again and again. Uh, I'll just show you a quick overview of the last parser, which is really not very like optimized, but it is something, the TSSG. So this SSG parser is like only a 300 like lines, and most of them are comments as well. So I'm using very like specific nodes processors. Like if you are going to process the identifiers, you only need to like have one exact processor for them, and that processor can like only go to them, like get some data, some cache identifier and the object itself, and it will return you the qualified OpenAPI spec. And similarly, we have the unary expression and object expression processors as well. And these processors are only responsible for the object expression. The unary is only responsible for the unary expression. And good thing is these processors can use each other, so that we don't need to repeat ourselves again and again. And it is very easier for us to like reuse the same code and write again and again. This was the first version of the parser that I worked on, and this is the, like, I put that example as well so that it is easy for me to go, so that I could write some test cases and stuff. So this raw object to parser was very, like, messy, because it was just calling the reducer again and again, and it has simple if else conditions and nothing else. So it was like rerunning whole process again and again, and there was no code reuse. I was repeating so many things. Then at one night I was going to, like, about to sleep, so an idea, like, clicked in my mind, and so I just woke up and I opened my laptop, and in 2 or less hours I rewrote this whole parser. And this took me like 1 and 20 minutes to be exact, 1 hour and 20 minutes, like, to rewrite this whole parser. And it is way easier to extend and way easier to, like, uh, uh, write, because you are just reusing whole things again and again. There is no need to, like, copy and paste stuff again and again. So, like, if we want to improve object expression, and if object expression we change something here, it will be automatically be reflected everywhere. We don't need to do anything like going there and changing the if conditions and changing stuff like that. So this is how we're going to, like, keep the next version as well. So I'll keep things like, we'll have such kind of uh, way where we can just be very explicit about the things, like we want this kind of syntax, and then we return only the object expression. And this is how the reducer reduces and calls itself, so that it start from other object node and go, like, into the depth of the last terminal. So this is a simple, like, look, I'm using the ES Prima parse script the similar way that we have. Look, I'm building this parser the similar way that ES Prima works. Like, we have, let me open this, and this test is also has this kind of, like, syntax. Parser.parse, passing the example string, and we have this location true, so that it displays the locations. And look at this, similar syntax. So I'm just keeping the AST as similar to AST parser, like, of the JS as well, so that it is easier for us to, like, reuse some of the things from here. So we do not need to repeat ourselves. So I hope this is already overwhelming, and you will be, like, thinking what things are going into, like, and it is very messy for now, but it will make complete sense once you like spend some time to understand this. So currently we have this TSSG parser private, as a private repository, but I'll just open source it after this call, and I'll just send you the link as well, and maybe I'll add you as a collaborators, so that you could just go and look at what we are doing inside this. So just make sure, if you have any kind of suggestion, or if you have any kind of, like, idea where we can improve the overall, like, either it's syntax, either it's something else, maybe it's a code that we can improve, just let us know. And just,
So we do create a issue over there, or we discuss?
look, issues is good, but the problem is we need to discuss with the like our this team, because what we want is, we must want it to be very clear for us that what is going to be, like, the final version is going to be look like if we have the complete sense of the syntax now, like, this is the final, like, decided version, syntax version that we're going to implement. So we'll have a clear picture in mind that these are the some things that we're going to have in your projects. So we'll only think according to that syntax. So we'll not, like, focus on other things. We need to focus on the syntax first. Once we are done with the syntax and we are confident enough that this looks good, we can just move and work on other things. And I hope, like, we can like participate into many areas. Like, some of us can work on the simple, like, the core parser. Some of you can just simultaneously work on the transformer side. Some of them can be, like, if, like, someone like Abdullah is good at front end, so he can just maybe work in the front end side, so that it could improve the overall user experience and the UI of the editor. So this is how, like, we can contribute in many ways. And maybe if you can only write the proper documentation for this, it's a huge contribution as well. So this is how like I'm just expecting people to like contribute in any way. Like you have all the things in front of you, and just pick something, focus on those things, like only one or maybe more than one, and just come up with some idea that really makes sense and that makes a difference, so that like we could improve the overall DX, the developer experience. This is what this tool is about. Akshay, do you have
Amazing.
anything to say?
I think the most of the thing mentioned by you are completely aligned. So majorly for everybody, that what is the major takeaway here is, first of all, that this is a great chance to have your mark in the open source space. And the second thing is, this project will somehow can be part of the real open API specification as well,
Yes.
because this is solving a major challenge. What is the major challenge here is that right now it's very difficult to write those Swagger APIs. Even if you know, it means it's there are high chances that we will do some mistakes. So somehow this is solving that challenge, and somehow this is solving a major this is helping in terms of the developer experience. So try to bring your thought, try to solve the challenge, and don't don't think that you should understand each and every part of it.
Yeah.
Pick up small things. Don't do like if you are good in documentation, write the documentation. If you want to solve a particular challenge, write that particular challenge. But the good thing is, first go through the Swagger specification. Just read about the Swagger and how to write the Swagger. Just try to do this and then come back on this, because if you don't have the good basics, it will be difficult for you to contribute.
Exactly.
Cool. Does
Okay.
anybody have
So,
any question?
Yogesh, do you have any input on it?
Well, first of all, I'd like to see how this thing works. Like, I would like to see the code and all these things.
Mm-hmm. So,
Then
like,
maybe,
what do you think about the overall syntax that I proposed, the draft version? So, do you think it makes complete sense to you? Like, if you are going to like use it, does it make sense that it is easier for you to like work with this kind of syntax?
yes. For me, it works very well. I mean, I'm able to understand what the syntax is and
Mm-hmm.
how it will be converted to the schema.
Mm-hmm. Okay, cool. So, Majid, do you have anything to say?
Yes, sir. The idea is definitely amazing. I mean, you write 4 to 5 lines, and the output is around about 20 to 25 lines. So it's a great idea,
Mm-hmm.
and you have implemented it. I'm really excited to use it and see how it works in my projects.
Cool. Thank you. Okay, Abdullah, how do you see this? I know that you mostly work on front end, but how do you see this project, and how do you think that it's going to help us in future, like as a developer experience? I think Abdullah is not here. Abdullah, maybe he's away. Okay, Pranjal, do you have anything, like any input on the syntax?
Syntax I need to research. I mean, I cannot
Okay, cool.
say for now, but
Yeah, that's good. That's good.
and I
I
haven't
think
seen
this is what
everything
I said.
as it.
We'll have a next session on next weekend, like the upcoming weekend, and we'll finalize all the things in that in that very day, because I want it to be like be finalized by upcoming week, so that we could start working on that. I was planning to first go and finalize today, but I think that you need some time as well, because you need to understand and research some of the things that make that may help you to like come up with some good ideas. So you definitely need time. So I'll just wait for the next upcoming, like the upcoming weekend, and once we are here, we will discuss. And maybe if you can just write a draft like this, like your own version like this, just don't hesitate, like to present your ideas. We are like working as a team, and we just want it to be uh, like in a, like the syntax which very completely makes sense to us and to others as well. Just don't think that I'm going to use it and it's good. Just think as if someone who is not familiar, very familiar with like TypeScript, but he wanna use this kind of syntax, or maybe if someone who is new, like the new joiners, or maybe the interns who really don't know about such kind of stuff, but it is easier for them to understand as well. So this is the reason like I was waiting for so many like weeks now just to propose this syntax to so like other people. I have like presented this to other guys in the group community as well, and two of them are ready to help, like contributing with a core parser as well, because they are well familiar with uh, BNF and CGF, CFGs, etc. So it will like help us to like uh, build something that really like makes a difference for the community, because this is all like it started from me. I face a challenge that it is very like cumbersome and tidy task for me to like go and edit something. So what I did is I came back home and I worked on the CLI part first. So I just had a very simple CLI for me where it just ask me some question and I'll just answer that and it automatically add that to my Swagger file. Then I kept thinking on how can I improve this for myself. And then one day I thought, if I'm facing this kind of challenge, maybe there are some other people who are like, then I removed this myself for
Yes, I
myself.
need to drop because I have another call.
Yeah, no problem.
Thank you.
Thank you so
Thank you,
much.
everyone.
You.
So, so then I just started working in a way that everyone should like could understand this kind of syntax. And then I worked on the syntax and worked on the parser, and then I created the POC so that people from around the world could see how this is going to benefit them, how this is going to save them some time. So many people really liked the idea and they really appreciated that it's amazing. It's like saving them time. Even I'm now using it in my like daily like day job routine, and I think Ming is also using, and Pranjali is also trying this. So it's like really helping me to like write some basic like the object schemas for now, but I wanted to go beyond those limits. So that's why we are all here today. So I'm really looking forward to you guys so that we could get some great contributions from you and really make something that really matters for the community.
So even after we make all the changes, are we going to use any existing code from this, or everything will be new? Even the parser will be new.
The, definitely, if we're going to have a different ASD, we're going to write a different like transformer. But I'll keep the ASD as similar to the ASD of JavaScript or ES Prima, so that it is easier for us to migrate, like to reuse some of the components or code from the old TSSG parser and put it in a new parser. So
Cool.
we'll have to like repeat ourselves, but very like less. So it will save us time, like developer time as well. So thank you so much, everybody, for joining and listening to me for like 1.5 hours. So I'll just wait, and I'll also share this material on the Slack channel as well. So make sure you join this Slack channel. Okay, so
Can
I
you
have
share
already
this?
invited you guys in the TSSG team. So just join it. And if you have any kind of question, any kind of confusion, just ask it here. You don't need to like there is no need to hesitate about like if it's a stupid question or it's something that really makes sense. Just ask your questions, because if you not gonna ask questions, you will not be able to understand the things properly. So just try to ask whatever question comes in your mind, and just let me know so that I could help you, or maybe someone else could help you on the channel as well. Okay, so I think this is it for today. I'll stop my share now. So
So there is one thing I want to discuss. Maybe after everyone drops, or I don't know. Maybe after the call.
maybe if they wanna like stay, they can stay and listen to our conversation.
Okay, cool. So there is one thing I can improve in the current this thing transformer, but I don't know whether it makes sense to do those changes now because anyways we are going to revamp everything.
But what is your idea?
So
If you
my
can,
idea, so currently we are using recursion.
yeah, you can share your screen. I'll.
I don't have anything to show.
Okay, so idea. Okay, I think you have something to show us as well. Okay.
No, no. So currently we are using recursion in the transformer, right? We can convert everything to a like everything is I think already functions. So we can use a reduce instead of using a recursive. We can use iteration. So that will save us a lot of
Yeah,
stack
we're
space
already
and
doing
make
that.
it
For the
faster.
properties, of any kind of object is going is using the same reduce, and we are passing that same reducer. It's already doing that.
No, but you showed us reducer is calling itself, right? Rather than
No. Reducer is not calling itself from within itself. It is being called from other processes. Like where you encounter a nested object, that particular object is going to be started with a very new reducer. Okay, so that it doesn't affect the other object schema. So it only starts from itself and then goes into it. And when once it's done, it will return like the computed result on its place, not to any other part. This is how it's
okay,
working. Like
because
we
I
have
thought
this properties dot reduce, and then we're passing that reducer because this is how every object is going to be like parsed. Because at very the top level we have the object parser. Okay, so what if we again like encounter a parser, like sorry, a parser its object. So
nested
if
object.
object, then nested object, then nested object. So the
Yeah,
problem
and you are using
is we are using a cache. Okay, the cache which is like which holds the whole uh the the tree. Okay, so then if we have the new one, we don't pass it the undefined as a cache, and then we do not pass it a new reducer, it will affect the whole tree and it will override all these. Okay, it will not like make a sense to use this kind of like way where it affects the whole tree. We only want it to affect or change something from where it starts. So like if it starts from the level 2, it should only be working with the level 2 of the data. It doesn't need to know what is like in the level 1 or above it. I tried that and it was like very messy for me to like redo the things because it was replacing all the data, and sometimes it was replacing some existing keys. Like if you have the name key in like higher version, like the level 1 version, and then you have something that is nested and it has the name key as well, it was replacing that. But now it doesn't do that because if you see the code, you see that whenever a new object starts, it is passing the empty object cache. Okay, so then it starts its own root node from that and then computes all uh, the data, like computes all the things, and then it returns only at the point where it was encountered. So it is way easier for us to build the and reduce the whole structure.
okay, okay.
I'll explain you sometime later as well. Does it make sense now? Maybe not.
I'll go through it again. No worries.
Cool, no problem, man. Even you can
Yeah.
just try that, like change something and then check the output in the console, like just console.log that, and you'll see the changes into the ASD. So if it changes something into the like the first, like the level 1 version, the area where it doesn't need to like change anything, it means it's doing something that we are not expecting it to do. So this is the reason I'm using that kind of syntax and just reusing the reducer from within the processors where it encounters new objects.
Okay. Cool.
Does it make sense now? No, it won't make sense until you try it yourself.
Yes, I know.
Okay, cool.
All
So
right then.
all right then, thank you so much.
Is it done? Does anyone have any questions?
Do you have any question, guys? Any extra question? Anything that is in your mind? Just ask. Yogesh, Majid, Abdullah, I think he has gone somewhere. He's not responding to my questions.
No.
Okay, cool.
No.
So I think everything is clear now, and you can just go and have a look at the existing repositories and the work I'll share in the Slack group. And just if you have any question in your mind, let me know. Thank you so much for joining this session, and I hope today you may have learned something that's new for you. But if it's something that is like interesting for you, just make sure you learn something that really matters and which helps you to build something that really matters. Okay. If you have any kind of confusions in learning something, or like if you are like reading about the PEC and you don't know how to do things, you can just reach out to me anytime and I'll help you figure out how you can improve your rules so that it parsed properly. So thank you so much once again. uh, okay, Ming, I think you don't have any question because you are already on the same page, because we have been discussing a lot on the parser and stuff like that. So I'll see you guys on
Yep.
the next session. Yeah, cool. So let's
Thank you.
let's shake hands in the next session, so that we could like finalize the version of syntax. And once done, I'll be happy to like push some code that I've already written. But I'm just playing with testing some of the things that, like you can say, experimenting. So once I'm done, I'll do that, and you will be able to see the whole work. So thank you so much. Bye bye.
See you. Bye
Bye
bye.
bye. See you.
Bye.